Now, of course, to say 1 to 1.5 is inappropriate for mathematics, so we could say that you actually produce a 3 to 2 ratio. Get that decimal out there. So for every 3 ATP generated, you're likely to make 2 NADPH. So cyclic electron flow, which is what naturally occurs, it is the true process of photosynthesis of the light reactions, results in a little bit extra ATP that is produced. Now then you're like, well, that's cute. Well, you'll see very quickly that actually, like, this is a requirement. This isn't just like a relic, that this is an accident that could happen and you have bonus ATP. It's a requirement. So this has to happen. Are we cool with this drawing in this picture? It serves as the reducing power. It serves as basically the H's to add back to CO2. So you can remake the glucose or the sugar. We cool with this? It's a holder for H's as you start to put them back on.
Is the extra ATP for glycolysis?
Nope. The extra ATP is to drive the next set of reactions. Remember, photosynthesis is made of 2 parts, right? The light reactions and the dark reactions. You've just seen the light reactions, the light requiring reactions. Why is there light there? Well, basically to excite your electrons and cause the splitting of water. So now we need to get into the dark reactions, which are also known as, or is also referred to as the Calvin cycle. So let's title our page that. This is kind of the second half of the day. These are the dark reactions. Also known as the Calvin cycle. The first thing that needs to be mentioned excuse me, is the requirements. It requires ATP and NADPH. Where does the Calvin cycle, the dark reactions, where do they get that from?
The light reaction.
Very good. And when we look at the series of reactions, we see that it is very close enough that I don't mind writing it. It's close enough to the direct opposite of the Krebs cycle. Bless you. You're welcome. Remember, in the Krebs cycle, what's happening? What are you producing 4 of? 4 CO2. Very good. How many NADs or NADHs are you producing? Very good. 6. How many FADH2s? Very good. Is that it? What else do you produce, Travis? Say, Brad. How many? You sure? It is 2. 2 ATP. Right? Okay. So you're producing CO2, some reducing power, right? Some NADH and some ATP. So it would make sense that in the Calvin cycle, you take in CO2 and ATP and NADH to re-put or to reform your glucose molecule. Maybe I need to say that again so everyone catches that. In the Krebs cycle, going down the steps, this is what you did in cell respiration. Remember, you pulled off H's and electrons and stuck it into NADH. Also, along the way, you made some ATP. Not a whole lot, but some. Also, your NADHs accounted for some ATP that resulted in ATP production in the electron transport chain and chemiosmosis. Well, in photosynthesis, specifically in the Calvin cycle, the dark reactions, which is what we're talking about on this page, you'd be going up the steps. You would be reforming the sugar instead of breaking it down. That means you would require the reducing power, the ATP, the NADH, as well as CO2, which was blown off in respiration but would be required in photosynthesis.
Why is there 2 NADH?
I'm just showing you the excessive amount of NADH that's formed. Right? I mean, it's pretty logical to think about. Plants are going to take in CO2. They're going to make a sugar, maybe C3H6O3, or maybe C6H12O6. You could name a variety of sugars at that time. But I think one thing you're going to notice between those sugars is that they all have hydrogens in them. And they're all complex. They're all anabolic. They're all having a spontaneity that is unlikely. So you're going to need to power them. You're going to need H's for them. Good? There's 3 parts of the Calvin cycle. 3 different phases, 3 different time frames. The first is the pulling together of all of your carbon dioxide. We call that carbon fixation. This pulling in of all of the CO2s. This process is catalyzed by an important enzyme that you need to know. Rubisco. One of the few enzymes out there that does not end in ACE.
What is that?
Just the name,
Was it a man named Rubisco?
probably.
No, no.
Step 2 is to do a series of reduction events. You're going to reduce your carbon compound. When you're reducing the carbon, what is that? Let's think about that. Yeah, you're starting to add back your H's. Very good.
How does that add
Do it.
How does that add
It starts using up all of the NADH that you've accumulated enough energy to do something so anabolic. Such a buildup, such a complex molecule being formed. So you might want to jot down at the very, very end that in your Calvin cycle, during this reduction phase, there is the use of 9 ATP and 6 NADPHs. The 3-to-2 ratio.